Alright, so tomorrow my Year 7 class have a test on fractions, decimals and percentages. Now I gave them a bit of a practice sheet today to go through, and so I noticed a few people were struggling with a few things. So here I am, I've come home, I've grabbed my cup of tea, what have I got? I got some toast with apricot jam on it, and we're just going to knuckle down, whatever, for the next 10, 15, 20, 30 minutes, however long it takes. I'm going to go through the solutions to the practice questions that I gave, so that, and then I'm going to email this out to my students. But I'm going to throw it up here on YouTube as well for anyone who might be interested. Fractions, decimals, and percentages. Now, the first row, the first lot of questions are non-calculator ones. So I want you to try and have a go at these without your calculator. So pause the video, have a go at this, and then you can unpause it and see if you got the same answer that I did. Simplify 18 over 24. So we're gonna break that down to a smaller fraction. Now there's a couple of strategies you can use. You might have been taught you can find the highest common factor. My guys, we in class talk about something. I think I made this up. I don't know. I've never seen it before. It's called the 2357 rule. And we're going to just chip away at this fraction. The first thing is, can I divide it by 2? Can I halve both of those numbers? Yes, half of 18 is 9, half of 24 is 12. Right? Can I break that into 2? Can I break this bit here into 2? No, I can't. So I can finish with the 2's, and I'm going to move on to the 3's now. Can I break them into 3's? Are they divisible by 3? Well, yeah, 3 fits into 9 3 times, and it fits into 12 4 times. I can't go any further. I can't fit 5 or 7 into those, so my answer is 3 over 4. All right, next question. 3 over 7 plus 2 over 7. So the key here is that these denominators are the same. And when the denominators are the same, I can add and subtract, right? My answer will be the same denominator. So it's going to be something over 7. That doesn't change. I've got 3 of them. I add another 2. I've got 5 sevenths. Done, right? We've added fractions that have what we call a common denominator. Now you'll notice in this one though, that's not the case. The denominators are different. So once again, there's a couple of strategies. If you're listening or watching this and you've got a teacher other than me, you might have been shown to find the lowest common multiple. That works. My little method I like to teach my guys is this. I'm going to rewrite the fraction, and my new denominator will be these multiplied. So 3 times 5 gives me 15. Both of them are 15s. So basically I'm going to create 2 equivalent fractions. Now, 2 strategies. You could look at this and go, well, what did I do to the 3 to make it a 15? I multiplied it by 5, so I do the same to the top. What did I do to this 5 to make it a 15? I times it by 3, so I've got to do the same to the top. Okay, that all works. However, if you're in my class, you would have seen, let me just fix this up, a slightly different thing. Once I get to this point, I'm going to just multiply across the plus sign. 1 times 5 gives me 5. All right, I just multiplied across here. 3 times 1 gives me 3. So they're my new numerators. Okay, I'll just put that in there. We kind of multiplied across the plus sign. And now you can see I've got fractions that have the same denominator. So I can add them. I've got 5 fifteenths plus 3 fifteenths gives me 8 fifteenths. All right, I can't break that down. I can't split those numbers in half. 3 doesn't fit into them. 5 doesn't fit neatly into both of those. I'm going to leave that as 8 over 15. Same with this question. I've got a half, take away 1/5. The denominators are not the same, so I'm going to make them the same. Okay, I'm going to rewrite my fraction. It'll be something minus something. 2 times 5 gives me 10. So I'm multiplying these numbers together to get my new denominator, and then I'm going to multiply. I'm going to cross multiply across the plus or the minus sign. So 1 times 5 gets me 5. 1 times 2 gets me 2. Right, so I went 1 times 5, and then I went 1 times 2. 5 tenths minus 2 tenths gives me 3 tenths, because now the denominators are the same. I can simply go ahead and subtract them. All right, and I know we're going through this pretty quick. It's just a review, so feel free to pause or rewind if you need to. The trick with multiplying fractions is these are actually easier. Multiplying and dividing fractions are easier than adding or subtracting them. We multiply the tops, all right, and we multiply the bottoms together. So my fraction across the top, my numerators will be 1 times 1 is 1. Across the bottom, 2 times 5 gives me 10. Done. I told you they were easier, didn't they? I'm going to pause for a second, have a sip of my tea. All right, let's keep going. Now, dividing fractions, there's one little trick. They're pretty easy, but we need to flip the second fraction upside down, and our divide becomes a times. So let's do that. The 6 over 11 I don't touch. I flip my 2 over 3 upside down. In other words, I create what we call the inverse, right? Which is when I turn a fraction upside down, and my divided becomes a times. Now, using what we just did in our previous question, you can see I multiply the tops, I multiply the bottoms. So 6 times 3 on the top is 18, 22 on the bottom. Now, can I simplify that at all? Let's apply my 2, 3, 5, 7 rule. Can I divide those by 2? Yes. 18 and 22 are both divisible by 2, and I get this. Now, I can stop there. I don't need to go any further because I can see 11 is a prime number, so it's not going to break down any further. So my answer is 9/11. All right. Okay, the wording of this one threw a few people out. How many halves are in 12? All right, think about it this way. If you had, I don't know, 12 watermelons and you chop them all in half, how many halves do you have? Well, you've got 24, don't you? You've taken each one, you've chopped it into 2, right? You've halved them, so you've got 24 pieces. So there were, whoops, Daisy, let's go with the pen, 24 halves, okay? 12 is a whole number, and if I split each of those in half, I'm going to get 24 halves. So if I could check that, I suppose we're going 24 times a half equals 12. It's the reverse thing. Right, so think about it that way. How many halves are in a number? Well, split each one of them in half, and how many pieces do you have left? I know that one, the wording, I think, threw a few people out on that way. Hey, write these in a simpler way, and you'll notice these are both what we call recurring fractions. There's a number that goes on and on and on, so we call them recurring fractions. So how do we write them in a way that doesn't go on and on and on and on? I can see this pattern repeats. 1, 2, 3, 1. Right, let me just fix that up. The 1, 2, 3 bit repeats. The 1, 2, 3. The 1, 2, 3. 1, 2, 3. So that would go on and on and on forever. So I write that as 0.123. Now I put a dot above the first and the last digit that are the repeating pattern. So what that means is everything between the 1 and the 3, right? Each one of these numbers repeats. Now, you might have seen some other ways where you put a bar over the top or 3 dots. They're all, I guess, correct. There's different ways of doing it. Just know in the New South Wales syllabus, this is the way that we indicate a recurring decimal. So the same with this one. It's the 4, beg your pardon, it's the 4 that goes on and on and on. So all I do is I put a dot over the 4. 1.4. Is my cursor annoying you there? Let's push that to the side. Yeah, sorry if that was in the way. Yeah, that's it. Round the following. So we're going to chop these down to 1 decimal place. So I'm going to chop that right there. Now, remember we said when we're looking at rounding decimals or numbers, we look at the one after the chop, right? I call this the critical digit. So I'm going to write that on there. Okay. If the critical digit is 5 or more, we round it up. If it's not, we leave it as is. In this case, 2 is clearly not 5 or more, so my answer will stay as 6.3. But in the next one, oops, daisy, I'm chopping it after 1 decimal place, so that's 1 number after the decimal, then I chop it. I look at the critical digit, in this case it's 7, which is 5 or more, so my 0.2 goes up 1 to 0.3. Both of those answers have 1 decimal place. Hey, my toast's going cold. Hang on a second. Whoops. I have really bad manners, I know. Sorry. But I'm hungry. All right, rewrite these in ascending order, which means from smallest up to biggest. So I'm looking, they're all decimals. So first of all, I'm going to look at the tenths column. And I can see that this one here has a 0 in the tenths column. So that's definitely going to be my smallest one. So that's going to be my first. So let's write it here. 0.01. Let's cross it out so I know I don't get confused. But the other two both have 1 in the tenths column. So I need to move along and have a look at the hundredths column. Now I can see in the hundredths column, right, if I was to put some trailing zeros on this one, they'd both have a 0 in the hundredths column. So that doesn't help me. So I'm going to have to look at the thousandths column, right? In this case, that's a 0 for here, and this one is a 1. So that is the biggest number, right? Because I've got to keep working along to find which one has the highest digits in each place value. So I can see that the next highest one is 0.1, and 0.101 is the next highest. They're going up in ascending order. And if they're tricky digits like that, we're just looking at each place value and trying to decide which has got the highest digit in that place. That will be the higher number. Now, 6.125 times 1,000. Our strategy for doing these, I hope you remember, is when we're multiplying by tens, hundreds, thousands, 10,000s, all we do is we count the number of zeros. In this case, there are 3 zeros. And when we multiply, we move the decimal point that many places to the right. So in this case, it's going to be 3 places to the right. I can see that it starts here, and I move it 1, 2, 3 places. So it ends up after the 5. So my answer is 6125. I moved the decimal because it's a whole number. There's a decimal there. And remember, we also said if I want to, I can put some trailing zeros, but that's just to show you, I guess, where that decimal point is. So when we multiply, we go to the right. Divided, which we're about to do, we go to the left. So let's do that. I've got 2 zeros, so I'm going to move it 2 places, and it's divide, so I'm going to move it 2 places to the left. So I'm going to take my decimal point, which is here, and move it 1, 2 places. So now it ends up between the 6 and the 3. All the other numbers stay the same, 6.317. All right, we haven't used a calculator at all yet, because remember we said this is our non-calculator section. And we nearly finished that section. Convert these to percentages. All right, I'm going to pause for a second, eat some toast. All right, I'm back. So a couple of different strategies for these. Most of the time, fundamentally what we're doing is we're multiplying by 100. When we take a decimal or a fraction and we convert it to a percentage, we're multiplying it by 100. So 0.7, beg your pardon, that should be multiplied. Oh dear. Multiplied by 100. And remember, just in that, like we did in the previous question, that means moving the decimal point 2 places to the right. So I don't have any places there, so I can put some trailing zeros, and I move it 2 places, and it ends up after the first 0, so it's 70%. All right, multiplying by 100. Let's see if we can do the same thing now. Having a look at, let's go across to question B. Question B, I'm going to use a bit of a mental strategy. Rather than multiplying by 100, I know that half of something is 50%. These are some mental strategies we covered in class. So if a half is 50%, well, a quarter is half of a half. So half of 50% equals 25%, okay, using our mental strategies. All right, for question C, what I'm going to do first is I'm going to write this as a decimal. I'm going to do this in 2 steps. Okay, 9 over 100, so that's 9 divided by 100. Now remember, we're all in the non-calculator section, so we're doing this without calculators. 9 divided by 100, so I'm going to take my 9 and I'm going to move the decimal point. We're dividing by 100, so we move it to the left, 2 places. So I'm going to put some leading zeros and move my decimal point 2 places. So I get 0.09. All right, that got it as a decimal, but to turn that into a percentage, I times that by 100. So I'm basically moving the decimal point back to where it came from, and it's 9%. So that was a bit of a complicated way of doing it, but mathematically that's correct. That's what's happening. You might remember that the word percent or percentum is Latin for by 100. In other words, divided by 100. So in other words, you could have just looked at that and said, well, 9 divided by 100 is 9%. But if you weren't sure, mathematically, you could work that out by doing that little process I did. All right, D is going to get a little bit funky. Are you ready? It's 1/8. It's a bit of a weird one. So that means 1 divided by 8. That's what a fraction is. So I'm actually going to do a division algorithm. In other words, how many times does 8 fit into 1? I'm going to put some trailing zeros after the decimal. And remember, our process for doing this is I put the decimal in the same place in my answer. How many times does 8 go into 1? It goes 0 times with 1 remainder. How many times does 8 go into 10? Well, it fits once with 2 remainder. How many times does 8 fit into 20? Well, it fits, let's see, twice with 5 remainder. Beg your pardon, with 4 remainder. Right, and how many times does 8 fit into 40? 5 times with no remainder. I can stop now because I've got no remainder. So 1/8 as a decimal is 0.125. Now, remember, to get that into a percentage, we multiply it by 100. So if I've got 125 multiplied by 100, I move the decimal point 2 places to the right because I'm multiplying by 100. 12.5%. Now, there's a little bit of work in that one, but it was doable without a calculator. 12.5%. All right, guys, that's the end of our non-calculator section. Okay, all of those questions we just did, you'll be asked to do something similar without a calculator. The next column we're going to work through is our calculator section. All right, so some of these we might be able to do without a calculator, but I'm going to show you calculator methods for just checking to make sure you've got it right anyway, given that this is in the calculator section. All right, here we go. Are 3/7 and 9/21 equivalent? In other words, are they the same value? They just are equivalent fractions. Well, I can see without a calculator, just looking at it, they are, because 7 times 3 gets me 21, and 3 times 3 gets me 9. So in other words, if I multiply both of these values by 3, I'll get 9/21, which means they're equivalent. Now, could I check that in my calculator, my handy dandy Casio FX82? I can. Let's pull it up, and I'll just show you how you could check that. I'm going to put in the fractions. So this button here is my fraction button. I'm going to put in the bigger fraction, 9, down cursor, 21, equals, and you'll see the calculator gives me the simplified, the simplest version of that fraction, okay? 3/7. So it's the same value. Now, if you got this as your answer, a decimal, your SD button, every time you hit it, will toggle between a decimal answer and a fraction answer. So yeah, I could double check it with my calculator. So yes, they actually, let's just put that aside. They actually are. Yes. Oops. Yes. Right, 4 3/8 as an improper fraction. That's a fraction that has a higher number in the numerator on top than the denominator. Once again, I can do this without a calculator, but I'm going to check it with the calculator. So when we did these, hopefully you remember, we took 4 3/8. We multiplied here first. We did the 4. That's terrible. I'm going to cross it out. I'm going to rub that out. That's so messy. So messy. All right, we have got 4 3/8. So we take, that one's not much better, 4 times the 8. We go 4 times 8, which is what? 4 8 32. And then we add the numerator. So that gives me to 35. So my answer will be 35 over, now the numerator doesn't change, sorry, the denominator on the bottom doesn't change. Okay, I went 4 times 8 is 32, plus 3 gives me 35, and I keep the same denominator. Let's check it on the calculator. Is there a way I can do that? Let's just pull the calculator in so that we can see it. All right, let's clear it from the last one. So let's put it in the calculator. I'm going to put in the 4 first, the whole number, 4. So 4 3/8 is 4 plus another 3/8. So I've got to put in the plus sign, otherwise the calculator will get a bit confused. 4 3/8 equals, and there's my answer, 35/8, which is exactly what we had here. Once again, if you got a decimal, just toggle between the decimal and the fraction there. All right, so we checked it with the calculator. We're all good. This one is going reverse. We're starting with an improper fraction because the numerator is more than the denominator. And we're going to go back to a mixed number that has a whole number in the front and a fraction part after it. Our process for this was saying, well, how many times does 3 fit into 11? All right, it fits into 11 3 times. So that will be my whole number at the front with 2 remainder. So that will be the numerator. The denominator stays the same. It's 3 2/3. Okay, 3 fits into 11 3 times with 2 remainder, but my denominator stays the same. Now, can I check that in my calculator? I reckon I can. Let's have a look. All right, I'm going to put in the fraction, 11/3 equals, and it tells me 11/3. How does that help? That's just the same answer. Well, if you hit the shift button before your SD button, it will convert that to a mixed numeral. Okay, so normally if you just toggle it without hitting shift, you'll get the improper fraction and the decimal. With the improper fraction showing, hit shift, then the SD button, and I can see that 3 2/3, which is exactly what I got. Good sign. We must be on the right track. You guys are amazing. Which is smaller out of these? Well, the best way to do this would be convert them all to equivalent fractions, and then we can compare those. So I'm going to leave the 3 out of 10 as it is. 3 over 5. Now, to make this with a base of a denominator of 10, I have to multiply the 5 by 2, which I have to do the same to the top. So that will be 6/10. This one, to make it a 10 on the bottom, I have to multiply the denominator by 5, which I do to the same on top. So I end up with 5 over 10. So now I'm comparing which is smaller, 3/10, 6/10, or 5/10. Well, pretty obviously, it is the 3/10. It's the smallest of those three, but we can only compare them once we've got the same denominator by making these equivalent fractions. All right. 4 1/4 minus 2 1/2. Now a little bit of work to be done here, because remember back in our non-calculator section when the denominators were different, which they are here, I had to modify them so that they were the same. Now this one, no, I'll explain it as we go. First thing we want to do though is I want to put these into improper fractions. So let's do that. I'm going to convert them. So 4 times 4 gives me 16 plus the 1 gives me 17. So I've got 17 over 4 minus, now my second fraction, which is this one, and do the same thing, right? 2 times 2 is 4 plus 1 gives me 5. I got 5 over 2. Now, two ways you could do this. It depends. If you want to just stick with the method I've been showing you, which I'll do it this way, you'll get the right answer, but there's just a little bit more work. There is a bit of a shortcut here. We might come back and show you the shortcut at the end. Now, remember I said when the denominators are different, we're going to rewrite the fraction, and our denominator will become the multiple of the two bottoms. So I'm going to do 4 multiplied by 2. So my new denominator will be 8, and it's the same for both fractions. I multiply across the sign, so 17 times 2 gives me 34. And 4 times 5 gives me 20. So now I've got fractions that have the same denominator. So I can go ahead and just subtract them. 34 eighths minus 20 eighths leaves me with 14 over 8. Can I simplify that down? Yes, I can. I can halve both of those numbers. So I get 7 over 4. Can I write that as a mixed number? Yes, I can. 4 goes into 7 once with 3 remainder. Okay. 1 3/4. Now, there was a little bit of a shortcut back in there, back here. Instead of writing this as 20 over 8, for those of you who can see, there's a bit of a shortcut. You could have written that equivalent fraction as 10 over 4 and just simply taken that away from the 17 over 4. If that works for you, go for it. But I'm quite happy. It's one extra step, but at least we've got a method that works every time for doing that. Okay. All right. Good job. Well done. Now, 3 minus 1 over 7. So the trick here is to realize that we can write any integer, in this case 3, any whole number, as a fraction like that, 3 over 1. Okay. 3 over 1 minus 1 over 7. And now it's just a fraction question where I've got a different denominator. So I'm going to go ahead and follow my little process. I'm going to rewrite them. Right, with a minus. My new denominator will be 1 times 7, which is 7. Cross multiply, so 3 7s are 21. 1 times 1 is 1. Right. 21 over 7 minus 1 over 7 is 20 over 7, which I can write as a mixed number, which is 2 6/7. Hope that made sense. Okay, it's the same process we've been doing. Now, there is a shorter way of doing that. If you look at it, if you've got another way of getting to that answer, go for it. But I just want to show you guys a process that I know is repeatable and it works every time. So the trick here was just realizing an integer 3 is the same thing as 3 over 1. All right, that was getting a bit messy, but hopefully you guys can pause and just go through it again as needed. 2 divided by a third. Okay, same deal. I can write the number 2 as a fraction, 2 over 1. Remember when we're dividing fractions, we flip the second fraction upside down and we change the divide to a times, which is exactly what I'm going to do there. Now I've just got a fraction multiplication. 2 times 3 equals 6 on the top. 2 times 1 is, sorry, beg your pardon, 1 times 1 on the bottom is 1. And hopefully you can see there, 6 over 1, any number over 1 is an integer whole number. So the answer will be 6. 1/5 of $20. Of 20, I beg your pardon. All right, so a couple of strategies you could do here. You could look at that and go, well, 1/5. So if I had $20 and I split that into 5 pieces, in other words, fifths, each piece would be $4. So there's my answer. 1/5 of 20 is 4. If I was to look at that mathematically, though, what's going on is I'm basically saying 1/5 multiplied by 20 over 1. So 1/5 times 20. So let's see if we get the same answer. 1 times 20 on the top gives me 20. 5 times 1 on the bottom gives me 5. 20 divided by 5 equals 4. Okay, same answer, just arrived 2 different ways. 12 out of 36 people were male. What fraction were male? Well, all I've got to do is put my smaller amount on the top. There were 12 out of 36 people. I've made a fraction. Now, it doesn't say to simplify, but it's good practice too. So can I simplify that fraction? Well, first use my 2, 3, 5, 7 rule. Can I break them down into 2s? Can I halve both of those numbers? Yes, I can. 6 over 18. Right? Can I halve them again? Yes, I can. 3 over 9. Can I halve those? No, I can't halve 3. So can I divide them by 3? Yes, I can. 3 fits into 3 once. It fits into 9 3 times. I can't simplify that anymore. 1/3 of them were male. Right, 323 over 1,000, which is a big fraction, as a decimal. All right, here is my little strategy for this one. My decimal, I've got thousands on the bottom. So my decimal is going to have to go out to a thousandths column. So I'm going to put 0. Okay, something, because this is my tenths column, this is my hundredths column, this is my thousandths column, and because I'm working in thousandths, I need my decimal to go out as far as the thousandths column. Once I've done that, I just take the number on top and I put it into those places. So my answer is 0.323. We are nearly finished. Right, 0.25 as a fraction. So it's the reverse, I guess, of what we just did. Okay, I've got decimals that go to the tenths column and the hundredths column. So my fraction is going to be hundredths. So I'm going to put something over 100. It's these two numbers that go on the top. It's just the reverse of what we just did. Okay, I had digits out as far as the hundredths column, so my fraction will be a hundredth, something over 100. And it's the number on top, the numerator is just these two digits. Right, the following as a percentage. Now, for percentages, we've still got a few more to do. Sorry, I thought we were near the bottom. Okay, we'll keep going. A percentage is when we multiply something by 100, right? We had some of these in the non-calculator section. That one is going to be 7%. So remember we said that's what a percentage is. It's divided by 100. So that's already sort of presented in a way for us to go, well, it's 7 hundredths or 7%. So if you wanted to do it mathematically, you could do what we did in the other one. I'll quickly do that anyway. 7 divided by 100 means I move the decimal point 2 places. So I'm going to put a few leading zeros. And I end up here. Equals 0.07. I times that by 100, which means I move the decimal point back 2 places and I end up with 7%. Right, we did that in the non-calculator section. Mathematically, there were 2 steps there. If you can't remember straight up that's 7%. 0.32 is a bit easier because all we're doing is we're multiplying it by 100. In other words, I move the decimal point 2 places to the right. It's 32%. Finally, 3/5. Let's do it mathematically. Let's do it the long way. That's the same as saying 3 divided by 5. In other words, how many times does 5 fit into 3? Right, put the decimal in the same spot. 5 fits into 3 times, 0 times with 3 left over. 5 fits into 36 times, so it's 0.6. And I'm going to times that by 100. So I'm going to move my decimal point, 2 places to the right. So I'm going to put some, that's what I was going to do. I was going to put some trailing zeros, move it 2 places, and it equals 60%. Now, guess what? I forgot this was the calculator section. So let's redo those using the calculator. Okay. In fact, let's go back and do, let's do from here. All right, my bad, because I forgot this was the calculator section. So you could do them without the calculator. What am I looking for? I'm looking for my calculator. But let's just quickly check them. All right, 323 over, right, because make life easy. I'm going to create a fraction, 323. On the bottom was 1,000 equals, now remember my SD button, that puts it as a decimal, right? Which is what we got, 0.323. Right, 0.25 is a fraction, so I can go 0.25 equals, and once again hit my SD button, and it comes up as, oh, a quarter. I forgot to simplify it. I put it as 25 over 100, which is right, but we can simplify that down to 1/4. What about the next one? These 3 that we just did. Let's see if we can do them quickly and easily in the calculator. All right, 7 over 100 as a percentage. So I'm going to put my fraction in, 7 over 100, hit equals, right? That's the decimal version of it. And remember, then we times it by 100 to get 7%, which is what we got. 0.32, right? 0.32 percentage is times by 100 to get 32. Finally, the other one we did was 3 over 5, so a fraction. I just put the 3 over 5. I just put in the fraction that we had. Right, equals, there's my decimal version of it. And remember, I need to times that by 100 to make it a percentage, and I get 60%. All right, all good. Sorry, we did them without the calculator because we are awesome, but we checked them with the calculator. 14 hours is what percentage of 1 day? Well, this is hours, this is days. I have to convert them to the same units. So that is 24 hours. In other words, I've got 14 hours out of 24. And I want to put that as a percentage. So I'm going to use the calculator. Put my fraction in. 14 over 24. Hit the equals. Right. Change it to a decimal. Now that's a decimal value, but to change that to a percentage, I have to times it by 100. So let's do that. Times 100. And I get 58.3% rounded to the first decimal place. All right, find 120% of $3. Let's just zoom that up a bit. We are nearly finished now. Now, remember I said we never ever use the percentage value. We always convert it to a decimal first by dividing it by 100. Now, if you can't do that without the calculator, let's do it with the calculator. 120 divided by 100 to turn it into a decimal is 1.2. And that 1.2 is the number that we multiply our original amount by. So 1.2 multiplied by 3, so we can do that in the calculator, equals 3.6. All right. But we're talking about money, so we have to write it in currency. So that has 2 decimal places with a dollar sign. $3.60. All right. 120% of that gives me $3.60. Now, last 2 questions. Increase this 320 by 7%. So here's the little tip I gave you guys, that when we're increasing, we add our percentage to 1. And when we're decreasing, we take it from 1. We did this in class, but let's just review what it looks like in a question. First of all, I need that as a decimal, 7%. When I put that in the calculator, divide it by 100, I get 0.07. Because I'm doing a percentage increase, I add 1 to that. So in other words, instead of 0.07, I add 1. Whoops, daisy. I add 1, and it becomes 1.07. Okay, so I'm going to do 1.07 times my starting amount of 320. Gets me, let's do that in the calculator. 1.07 multiplied by the amount we started with, which was 320, I get 342.4. Okay. The last question, decrease by $50 by 9%. We take the 9%, we convert it to a decimal. When you divide it by 100, you get that, 0.9. But because it's a percentage decrease, we take that away from 1. So 1 minus my 0.09 gives me 0.91. That's the number that I'm going to use to multiply by my starting amount of 50. And when I do that, I get, let's just move that over so you can see it, 50 times 0.91, 45.5. But remember, because it's money or currency, we put it as 2 decimal places with a dollar sign. That's it. We got to the end. I know some of that we went through quick, but this is all review, so hopefully this is all stuff we've done in class. And if there's anything you're still not sure of, go back, pause it, rewind, have a look at some of those questions. If you can do pretty much everything that's on that sheet, you're going to smash the test. So good luck, and I shall see you guys tomorrow. Well done.